be increased to the greater extent as compared to the two-leg transformer. The auto transformer is very much advantageous. Okay, but you can't use everywhere, but wherever it is possible you can apply. In place of a two-leg transformer you can apply it. So now let us see the auto transformer. You can use it as step-up transformer or step-down transformer. This is a tap. You can use it as a tap. Say this is a load applied. Now here it is V2, I2, say ZL. Say this is N1 up to this, and say this is N2. This is I1. This is V1. Okay, so primary winding of the transformer is what? N1 as well as N2, both together. Turns are included. But in the secondary side, only this particular part is included. So obviously this is a step down, yes or no? So this is a step down transformer. So what is the relation that you can maintain here? In this case you can use, okay, this is what the dot, and here is a dot. Understand? So what do you get here? V2 by V1 is, or else V1 by V2, N1 by N2. But it's not N1, it is N1 plus N2 total. So what do you get here? 1 plus N1 by N2. So V1 by V2 is equal to 1 plus N1 by N2, which is also nothing but I2 by I1. Better use this also, because you already know that, okay? You already know that V1 by V2 is nothing but I2 by I1. So step down transformer will be like this. Step up transformer will be definitely like this. So VS1, this is AB, let us say. V1, this is I1. Now say this is N1. Now this is what? N2. This is the first case, second case. Now this is the load, ZL. This is I2. This is V2. Understand? Now what about again V2 by V1 here? V2 by V1 is N1 plus N2 by N1. Yes or no? Because now secondary side, this and this one is N1, this one is N2, but what is the total N2? Tell me, all of you. Total effective N2 is what? N2 plus N1, both sides, right? So you will get now 1 plus N2 by N1. I guess you understand. Where now this one I have taken as N1 and this is N2, but whereas here this one is N2, this one is N1, this one is N2. So total number of turns on primary side will be, okay, total number of turns in the primaries, because I can say otherwise N1 total is N1 plus N2. N2 total is only N2. Whereas here N1 total is N1 and N2 total is what? N1 plus N2. So obviously when V2 by V1 is taken, you are supposed to take what? Total only. Yes or no? So here, this is N1 total. Let me write it again clearly. N1 total by N2. Therefore, N1 plus N2 by N2. That's it. Clear all of you? Okay. So this is also same way that I'm writing here N2 total by N1 total, which is nothing but this nothing but. So what about again the same thing is equal to what I1 by I2. This is how you deal with auto transformer, and very clear. I1 is entering at the dot. It is supposed to enter. It is entering. I2 is supposed to leave from the dot. It is leaving. I1 is supposed to enter the dot, primary side, entering. I2 is supposed to leave from the dot, it is leaving. So there is no problem. V1 is supposed to be at a positive terminal at the dot, it is there. V2 is positive at the dot, it is. Now similarly here also it is positive, yes it is. It is positive, yes it is. Therefore you will get here positive only, plus N1 T by N2 T, okay, and here also plus N2 T by N1 T. Understand? Okay. Similarly, current also I2 by I1 is also same way. I hope you understand the point. Okay. So please note down quickly. We'll do some problems on it. You note down. Meanwhile, I just copy one problem here. Problem number 10. Find the power rating of the transformer. A of the transformers A. There are two questions are given here. Volts. Yeah, the current flowing here I1, here is I0. So here the relation is I1 is I0 plus I2. So if it is I0, so I1 is I0 plus I2. Yeah, this particular portion may have some current because I1 here gets divided, isn't it? Hope you have finished this part, okay? Now the first case, let us see the power rating. What is the power rating here? So power rating of the primary S1 is 240 into 0.2, 48 volt ampere, yes or no? S2 is also 12 into 4, 48 volt. So power rating, volt amp rating is always same for the transformer, yes or no? Whether it is a primary or secondary, any calculation you take, the power rating should be same. Now B, the same two winding transformer or two leg transformer is constructed as a auto transformer. On the single leg they placed. Now you see the primary side 240 volts, but this was a 0.2 ampere, this was a 4 ampere. Assume that once it is connected, here it is 0.2 amperes is flowing through this winding. Okay, 0.2 ampere is the rating of that winding. 4 ampere is the rating of this winding. Yes or no? Then obviously when it is connected like this, when the 0.2 is flowing here, 0.4 is flowing, then obviously how much rating will be there here? 4.2, because 0.2 is leaving, 4 is leaving. Agree? All of you? Then 4.2 amperes. Now in case of primary and secondary calculations when you make, S1 will become what? 240 into 4.2. S2 is what? S2 means you are supposed to take the total voltage V2. Yes or no? What is the total voltage V2? Tell me. When they are magnetically coupled, no doubt. What is the voltage here? Tell me. This voltage will become 240 plus 12. This is plus minus, this is plus minus. They are placed like that. This is literally taken and put upon this particular winding like this. Look at this. It has come like this. But now the secondary terminals are here. This terminal is out. Then what is happening here? The total voltage will become what? 240 plus 12. What is the total current here flowing? How much it is flowing through the secondary? I2 is how much? It's not I2 actually. It is I0. We want I2. I2 is nothing but 4. So you just calculate it. I'm sure that you'll be getting 1008. Okay, 1008 volt ampere. 008 volt ampere. Please check this once. Understand all of you? This is how you calculate the rating. That is 10th problem. Now we'll go for 11th problem. The auto transformer itself again. Plus minus 120 at an angle of 30 degrees volts. RMS value. This is I1. No, he said it is V1. But this is a dot. Now here is a dot. This is 120 turns. This is 80 turns. I hope you understand. This is 80 turns. This is 120 turns. Now here is ZL 8 plus J6 ohm. Now here is plus minus V2. Now here is I0. Clear? I0 may be in the downward direction or upward direction, but usually on the secondary side, when you have it is a step-up transformer, the current will be upward only. I think in the case I have shown downward, please correct it. You can put it upward. Okay, doesn't matter if it is upward or downward. It's only a minus sign difference. Okay, but the question is find I1, I2, I0, and also find the complex power supplied to the load. What is the question? I1, I2 and I0. B is complex power supplied to load. That's it. Complex power supplied to load. I think you have noted down this question, right? I think it is available already in your classroom workbook. Now look at this. What is asking I1, I2, I0? What is the data given here? V1 is given. V1 is nothing but how much here? V1 is nothing but what? 120 at an angle of 30 degrees. This is available here. Understood? If you know V1, can't you find V2? Yes or no? Tell me first. If you know V2, can't you find V2 by ZL, nothing but I2? Yes or no? If you know I2, can't you find I1 because there is a relation between these two? If you know I1, I2, can't you find I0? If you know I2 and V2, can't you find what is the complex power supplied to the load? V2 into I2 conjugate. That's it. So therefore V1 is available. Therefore I find now V2. V2 is nothing but, what is V2 actually here? N2 total by N1 total into V1. Same time I'll take care of the dots also. There's a dot available here. At the dot plus is there. At the dot this also plus minus is there. There is no problem at all. Therefore it is plus only. So what is N2 total? N2 total is 120 plus 80 by N1. Total how much here? 80. What is V1 here? 120 at an angle of 30 degrees. Once you know V2, you will find A. I2 first. V2 by ZL. Once you know I2, you know that I1 by I2 is equal to N1 total by N2 total. That's again 120 plus 80 by 80. So you'll find I1 from here. Yes or no? So I just do I1 is nothing but into I2 is equal to I2. This value you can substitute here. You know that I1 plus I0 is nothing but I2. Then I0 can be determined I2 minus I1. That's it. Once you know I2, B, complex power supplied to ZL, V2 into I2 conjugate. What is V2 you know here? What is I2 you know very well here. You can just substitute and find the values. So I just give you the values here. Okay. I think all of you understand the procedure. Right. The V2 value, what you get here is 300 at an angle of 30 degrees. I2 value, what you get here is 30 at an angle of minus 6.87 amperes. I1, what you get here is 75 at an angle of minus 6.87. I0 here is 45 at an angle of 173.13 amperes. Once you substitute here V2 and all conjugate, you can get 9 at an angle of 36.87 kilovolt ampere. Underline this. That means you get 9,000 volt ampere. You will get 9,000 volt ampere. Okay, I think you finished this part. Okay, so let's try to solve the problems here. 12, 13, 14, 15, 16. Very simple. That's why I've given it a stretch. Okay, I think you already have the problems with your classroom workbook. Okay, so 12th one is asking LAB, the equivalent inductance. And 3 coils are there. 3 coils or 4 coils or a number of coils. The only thing you have to identify what is which coils are having magnetic coupling relationship. Understand all of you? Okay. This is 1, 2, 3, let us say. 1, 2, there is a coupling. 2, 3, there is a coupling. 1, 3 is also there is a coupling. Yes or no? And the dots are also indicated. Getting all of you? Dots are also indicated. So you know that when 2 coils are coupled, additive or subtract or flux aiding or flux opposing, you have the formula L1 plus L2 plus or minus 2M. Similarly, when n number of coils are connected like that, or 3 or 4 are connected, you have to use the formula L1 plus L2 plus L3. Now 3, right? Plus or minus 2 M12 plus or minus 2 M23 plus or minus 2 M31. The plus minus decided by whether they are connected in flux aiding case or flux opposing case. Now, if you take 1, 2, current is entering and here is leaving, flux opposing case. Therefore, 1, 2 means here a minus sign will come. 2 and 3, at 2 it is leaving, it is entering. That means at 3 it is entering, at 2 it is leaving. Therefore, opposing again. Minus M23, 2 M23. But in 1 and 3, current is entering and current is entering. That means flux aiding case. Plus. That's it, simple. So therefore, 4 plus 8 plus 10, these are the individual values. Now minus 2 times 4 between these two, minus 2 times M23 into 5 plus 2 times 2. That's it. Simple. So 2 into 2, 4. 4. 2 into 4, 8. Minus 8 plus 8 gone. Okay. What is this value? 10. 10 gone. 4 plus 4. 8 Henry is the answer. Understand all of you? Next. Coming to this now, he is asking V naught. This is dot. That means this is at higher potential with respect to this. Okay. So therefore the voltage, if he is not mentioning any polarities, by default it indicates that this is plus, this is minus. Now 8 volts, no polarities are indicated by default with respect to dot terminal. Okay. This is plus, this is minus. So now you want the voltage here, total voltage. Understand? KVL you can apply, or else you can use the touching concept. V naught is equal to, you're touching positive first, therefore plus 2. This is negative or positive? This is positive, this is negative. This is negative, this is negative, this is positive. Yes or no? You're touching negative first, therefore minus 8. So minus 6 volts is the answer. That's it. Similarly, if you take like this, you see, you're touching positive sign first, therefore plus 2. You're again touching what? Positive sign first, therefore plus 8. 10 volts. That's it. You understand all of you? It's very, very simple. Now coming to 15th problem, he's asking Zn. Okay? Zn is asking. Now I think the mutual reactance is given or not. Let me check once. Yeah, K value is given here. 0.6. Please note on this. 15th problem is expecting Zn. Understand all of you? Okay? 15th problem is expecting what? Zn. Look at this. If you want to find Zn, first you have to simplify this part. Both are inductors. If you find some x dash, how these two are connected in series, that result is parallel to x dash. That result is in series with 10. That is nothing but Zn. But to simplify this, you must know what? Mutual reactance. Self-reactance, but mutual reactance is not present here, but this is available. You understand? Okay. Now, you see, K is equal to M by L1, L2, root. Yes or no, all of you, okay? Or else M is equal to K times root L1, L2. Here I apply omega into M is equal to K times into omega root L1, L2. K times omega L1 into omega L2. So what do you get here? This is nothing but Xm. This is nothing but XL1 into XL2. I hope you understand this point. Okay, so therefore, you have these two. Then based on that, you can find automatically the XL1 and XL2. Then if you know that, you can find Xm. Or if directly inductances are given, here reactance is not given, inductance is given, you can find directly the M value. Yes or no, all of you? You no need to apply this one. In this case, it may not be useful, but you can also apply like that. Xm can be directly written as K times root XL1 and XL2, but in this case, it may not be useful. So let us find M. What is M? K times 0.6 root 12 into 10 power minus 3 into 30 into 10 power minus 3. This you determine first. Understand? Then you find Xm. What is Xm? Omega into M. But what is omega? Look at this here. The impedance is given, reactance is given. In that, what is this value also given? From this, can I find omega? 40 by 15 into 10 power minus 3. So use this to determine the Xm value. Once you know Xm, you see how you can determine. Okay, this is a parallel combination. This is a parallel combination. Okay, X equivalent. That means X dash. What is this simplification? Tell me. X dash. Okay. What is X dash? X dash can be determined, or else you can find first L dash. Then you find X dash. There is no problem. What is L dash? L dash is nothing but L1, L2 minus M square by L1 plus L2. Look at this. This is dot here. So plus 2M. You already have L1 with you, L2 with you, M with you. Substitute here. You will get L dash. Here I think Xm is not required. Okay. You don't need here. L1, L2, M. If you substitute here, you will get L dash. Then XL dash or X dash is nothing but omega L dash. What is omega? Here it is available. What is L dash? Here it is available. What is L1, L2? Here it is available. What is M? Here you already determine using this formula. Everything is available. Now what is Zin? Tell me, all of you. What is Zin? Zin is nothing but 60 plus J40 parallel with Jx dash. I hope you understand this. Jx dash, because the reactance, right? Jx dash plus 10. Only thing you have to find X dash here. I'll give you the answer. Please check once. Okay. The answer which I got here is 10.893 plus J 8.75 ohm. Please cross check once. Okay. Please cross check. You please calculate carefully. The calculation part is very, very important in the gate examination. Most of the people do mistakes. Simple mistakes. Simple calculation mistakes people are doing and losing the marks. So don't do such kind of silly mistakes in the calculations. Please note that answer. Then let's move on to the 16th question. I think you have in your workbook. Just let me read the question here. The inductance measured across terminals 1, 2 is 4 Henry when terminals 3, 4 are open. And it was 3 Henry when terminals 3, 4 were shorted. The coefficient of coupling would be. You understand? Okay. You need to find what is the coefficient of coupling. What is the formula for coefficient of coupling? Tell me, all of you. Just now we have seen. Okay, this question was asked in IES. Okay, so K is equal to M by root L1 L2. here primary LP is given, secondary LS is given. What is LS is also already given. Okay, such kind of problems better you deal with, converting the given one into, because you are shorting opening, so it's not easy for you to deal with. Better you convert that into conductively equivalent circuit. Okay, using T model better. Transformer to T model, already you know that very well. What is this actually? LP minus M, LS minus M. The dots are here, therefore it is becoming M. Okay, I gave two formulas when you have dots here and another, first dot here, second dot here. So this is 1, 2, this is 3, 4. In the first case, when 3, 4 open, what is the value given? 4 Henry. When this is open, L12 when you see, when this is open, this is neglected, adding these two, LP minus M plus M. So LP is equal to 4 Henry. In the second case, L12 shorted, 3, 4 shorted. When these two are shorted, what will happen? These two are in parallel and that result is in series with this. So LS minus M into M by LS minus M plus M, okay, plus LP minus M. So therefore what will happen? M gets cancelled. And this value was already given as what? 3 Henry. And you already know what is LP in this. LP in this. You know LP. You know total equivalent. You were already given LS value also. So substituting all these things here, you will get M value. Once you know M value, substitute here. Okay, you will get M value and substitute in this one, you will get the K value. That's it. Understand all of you? Okay, so please do that. I just give you M is equal to √2 you will get. Substitute all those values here. I'll just do that. LS is 2 minus M into M by LS is 2 plus 4 minus M. That's it. You simplify this, all this, and then you will get √2. Once you get √2 by LP is how much? Already got 4. This is also 2. So got cancelled. 1 by 2 and 0.5. 0.5 is the coupling coefficient value. Quickly note down that. We'll move on to another two problems we have. We just discuss. Please note on that. Meanwhile, I just take another problem. Let me read the question. The inductance matrix of two magnetically coupled inductors shown in figure 1 is given by L is equal to 5447 Henry. When the inductors are connected as shown in figure 2, the equivalent inductance of the system is. So simple problem. This was asked in IES. Plus minus V2 plus minus V1. This is figure 1. Figure 2 was this is A, B, D and C. So he's expecting this way. If you connect in this way, then what could be the value is just asking. Okay. So very simple. You already know the inductance matrix relationship. What is inductance matrix of any magnetic coupled circuit? L1, M, M, L2. Yes or no, all of you, okay? This is what the inductance matrix of the magnetic coupled circuits when you have dots like this. If you have dots reversed, then what will happen? L1 minus M, L2. Okay. Now, what is L1 according to this 5 Henry? L2 7 Henry. M is how much? 4 Henry. But how did you connect all this? The two windings here according to figure 2. And he's asking now what is the overall inductance when you connect like this according to figure 2. So dot is here, therefore here dot. Because to find the equivalent inductance, you must require dots. And what is connected B and D? That means these two are joined. So C is taken out. So the dot is towards C, not towards D, right? So between CD, the two towards C, therefore here it is available. According to the connection, I can indicate the dots, okay? And what is LAB now? These two are fluxating or flux opposing? Opposing, right? Entering and leaving. Therefore, L1 plus L2 minus 2M. What is L1? 5 plus 7 minus 2 into 4. This is 12 minus 8, nothing but 400. Understand? That's an answer. Clear? Which was asked in gate. J2 ohm. This was asked in gate, very simple problem. What is ZAB is asking? Problem 19 also asked in gate. Let me write it. Forty turns. Okay, so what is ZAB in 18? 3 coils are connected in series and reactants are given. Mutual reactance between 1, 3 and 2, 3 given, but there is no 1, 2, right? There is no 1, 2 mutual reactance means there is no magnetic coupling between these two. That means, okay, you understand that? Okay, there is no magnetic coupling between these two because there is no mutual reactance at all. So what is ZAB then? When 3 coils are there, so J5 plus J2 plus J2. Now plus or minus 2 times, but between these two there is no, right? So and 1, 2 there is no, but 2, 3 yes there is, but entering and entering, so therefore plus 2 times J10, and now 3, 1 entering and entering. Yes or no? Okay, so let me check once. Yeah, this is not entering actually, this is leaving. Okay. In the question, please refer the question once. In the classroom workbook, it is given as what? Dot here. So between 1, 2, there is no relation at all because there is no mutual reactance at all. Between 1, 3 and between 2, 3 given. Right? So between 2, 3, it is plus, but between 1, 3, it is minus 2 times J2. Got cancelled and J9 ohm is the answer. Now 19th question, the number of turns of the primary required to transfer maximum power to the load 2 ohm resistor is. That's the question. You please read the question in your classroom workbook. It is very clear. I repeat once again. The number of turns required for primary winding, the number of primary turns required for maximum power to be transferred to 2 ohm resistor. Understand all of you, okay? You remember the maximum power transfer theorem we discussed in DC circuits. Of course, in AC circuits also. The first and important condition is what? The load must be variable. Understand all of you? But do you have a load variable here? It's a constant. It looks like constant. But remember, in case of magnetic coupled circuits, better you refer this to primary and then you see whether it is really a function of or whether it is a variable or not. Understand all of you, okay? So now it looks like constant, but when you refer it to primary, what will happen? You already know that when you have a load on the secondary side and refer to primary side, what did you get? Tell me. ZL dash, what will you get? ZL by N square. Yes or no, all of you? Now here also number of turns is asking of the primary. That means 1 is to N, but N is N2 by N1. Already N2 was given 40 by N1. Okay, so N is a function of N1, but ZL is a function of N or not? Yes or no? So when you refer to primary with respect to these two terminals, what will you get, Nana? What will you get? Because an ideal transformer, it is clearly mentioned, and this is 8 ohm. Now it becomes what? Tell me. 2 by N square. Now the question is, number of primary turns required to transfer maximum power to the load. Understand all of you, okay? That means you are varying what? Number of turns. Primary turns. Do you have primary turns in this or not? Yes, you have. N is a function of primary turns only. Now the load consists of the primary turns. Primary turns are variable. When primary turns are variable, the load is also variable because load is a function of primary turns. Now load is variable or constant? Variable. Now maximum power transfer condition can be applicable or not? Applicable. You understand the point? See, when maximum power transfer theorem related problems are given, you should always think in this dimension. Whether load is really constant or variable. You generally identify it. But in case of magnetically coupled circuits, you have to carefully observe whether that load is a function of any variable or not by referring secondary to primary. Secondary side quantities into primary side. The load is now referred to the primary. Therefore, now you got 2 by N square. Now I can apply maximum power transfer condition. Okay. What is the maximum power transfer condition? What is that? 2 by N square. That is RL is equal to RTH. What is RL? 2 by N square. What is RTH? 8. So N square is equal to 2 by 8. N is equal to 1 by 2. But N is nothing but what? N2 by N1. 1 by 2. From this, N1 is 2 times N2, nothing but 80 turns. So if we can tune the number of turns of the primary winding to 80, then maximum power can be transferred to the load from the source. That's a very, very important point to be observed. Understand, all of you? So these are the variety of problems that we can see. There is no limit. I think we have seen enough number of varieties. Okay. Quickly note down this. In the magnetically coupled circuit shown in the figure, 56% of the total flux emanating from one coil links the other coil. The value of mutual inductance in Henrys is. This is the question, right? $4 and $5. I repeat once again, 56% of the flux emanating from one coil links with the other coil, then value of mutual inductance. What do you mean by 56% of the total flux emanating from the one coil to other coil? Coefficient of coupling K indicates what? How much percentage of the total flux emanating from one coil is linking with the other coil? Yes or no? So 56% of total flux emanating from one coil means, so that is nothing but actually here phi 12 by phi 1. It's nothing but, okay, into 100 actually. So that is nothing but 56% is giving. That means 0.56. Understand? So it's just M is equal to K times root L1 L2. What is K? 0.56. L1 is 4 Henry, L2 is 5 Henry. That's it. It's nothing but 2.5044 Henry is the answer. Right? This is how you can do simple problem. The term you should understand, 56% of the total flux emanating from one coil. He is mentioning 56% of the total flux emanating from the one coil is linking with the other coil, means coefficient of coupling is given. Okay? This is 20th problem asked in GATE. 20th problem. It is also another simple problem asked in GATE. Problem number 21. The load ZL is to be matched to a generator of internal impedance ZS. The turn ratio of the transformer required is. So what is actually given here? ZL. This is ZL. This is ZS. Okay. RS plus JXS. RL plus JXL. N1 is to N2. Okay. To be matched, he is saying ZL must be equal to what? ZS. That's it. So what is the turn ratio he is asking? So refer to primary. Load matching he wants to do, ZL is equal to ZS. So obviously you know that ZL dash, okay, must be equal to what? ZS. You can't make ZL is equal to ZS. Okay, when you convert into, or when you transform that secondary into primary, then you will get ZL dash is equal to ZS. Understand? Okay, so what is ZL dash? ZL dash is nothing but ZL by N square. That is nothing but ZS. So what is N square is ZL by ZS. What is N? Turn ratio it is, right? It is N2 by N1 is nothing but, okay, root ZL by, okay, ZS. Okay, this is how you can solve the problems. Okay, I stop the session here. You can refer a few more questions in previous GATE, IES or materials and textbooks. You can solve the problems easily. These are different varieties we have already covered. Okay. So this is the end of the magnetic coupled circuits.